Hi everyone, this is Damian Carlson from the vBrownBag, and today we're going to do a deeper dive on building an automation solution with AWS Serverless. The vBrownBag is a podcast by the IT community for the IT community. If you like this content, you know what to do. So in a recent episode, we discussed Meatgrinder, an automation solution that runs on AWS Serverless. In that episode, Chris Williams, a fellow host, suggested that we demo Meatgrinder live. At the time, I didn't have anything to run through the script, so we decided that we would record it and post it with the episode. So here it is. A much deeper dive into Meatgrinder. In this video, I'll show how the Meatgrinder works step by step, and I'll include chapters in the description in case you'd like to skip to an AWS service that interests you. This video is for folks that are interested in seeing specifics on how the automation works, or are interested in architecting their own event-driven architecture on AWS. If you have a lot of experience in these areas, this video will be a review. So the purpose of Meatgrinder is to make our lives easier. After we've edited a live video and are ready to publish it as a finished product, Meatgrinder does that for us by posting the video and its description to YouTube, making a new post on our website, and updating the RSS feed. Meatgrinder's automation is made possible through the use of many AWS services. We've got S3 for object storage, EventBridge for notifications and triggers, Lambda for serverless functions, Step Functions for orchestration, KMS for encrypted environment variables, and finally, CloudWatch for logging. The Meatgrinder automation solution requires a CSV file that contains the names of the thumbnail images, the video file name, a description of the video, tags for YouTube, and any extra YouTube playlists beyond our default playlist. The first step in the life cycle of a successful automation run begins with files added to an S3 bucket using the AWS command line interface. I'm not using any S3 event notifications here because destinations for those notifications are limited to a Lambda function, an SNS topic, or an SQS The only configuration necessary for S3 is to enable EventBridge notifications for all events in this bucket. So let's move over to the EventBridge configuration, which is pretty straightforward as it consists of a single rule. This event pattern acts as a filter for all of the notifications coming from the Meatgrinder S3 bucket. Here, I'm only interested in notifications about S3 keys with .csv at the end of them using the wildcard comparison operator. The target is a step function state machine, and I'm only passing the object detail as additional details like region, account, and bucket name are unnecessary for our use case. From here, we move on to the step functions interface. I'll be switching between the state machine definition and the details from a successful execution so you can see how it operates. Those with eagle eyes will notice the orchestrator definition is a bit different from the successful execution. And that's because during the course of capturing this video and writing the script, I realized the orchestrator was missing some logic, which I've added. So starting at the beginning of a step function workflow, the first state sets the configuration for the Meatgrinder function to 512 megabytes of storage and memory apiece. And now that I think about it, this is probably not needed anymore, but during the initial development, I wanted to make sure that the Lambda function wasn't running at higher settings unnecessarily. For the output of this state, I'm discarding the output that was generated from setting the Lambda function's configuration, and instead I'm passing the original input, the object detail, to the next state. Switching over to the execution side, you can see the object detail that EventBridge filtered and forwarded from the S3 notification as the input, and the output is the same. Back in the state machine definition, the next state is to invoke the Meatgrinder function. The payload being delivered to the Meatgrinder function is the output from the previous state, the object detail. So just a quick note, there are a lot of overloaded terms at play. We've got functions in the Lambda sense and functions in the PowerShell sense. I'll do my best to be very clear about the definition of the terms. So with that said, let's take a look at the PowerShell code for the Meatgrinder function in VS Code. The entry point for the Lambda function is defined in an environment variable, and I've chosen to name the PowerShell function handler, which takes two parameters, Lambda input and Lambda context. Lambda input is an object that currently contains the Lambda function's input data, which in this case is the object detail from S3, and Lambda context is an object that contains information about the currently running Lambda environment. Down on lines 24 through 40, the code parses the CSV file for the MP4 file name and then checks to see if that key exists on S3. If so, this code creates an object that eventually is converted to JSON and is the output of the function. With PowerShell on Lambda, it's important to remember that the last object in the PowerShell pipeline is the return data for the Lambda function. So this handler PowerShell function is what processes the input from a step function state and then responds with JSON, which is the output of that step function state. And in turn, that output can be used as input for a state farther down the line. This is the essence of how the Lambda Meatgrinder is orchestrated. So let's take a quick look at the CloudWatch logs to see what the Lambda Meatgrinder function logged. The top of the log includes output from the Lambda Insights extension layer, which collects information about the Lambda invocation in order to provide insight into those executions through CloudWatch. A bit farther down, you'll see where the handler PowerShell function begins logging the AWS PowerShell modules as they're loaded. And using the right-host PowerShell commandlet, I'm actually logging the Lambda input variable. And then under that is just more information from the script itself, including a bug where I didn't write the variable properly. Hooray! So let's go back to the step functions workflow definition. At this point, we have a CSV file that contains relevant information for posting the video and the video file itself. This choice state acts as an if-then-else, which allows me to create choice rules and the next state based on that rule. If the video isn't present, it will loop. If the Meatgrinder PowerShell handler function has responded with stop, the step functions workflow will end. If the action is set to upload, we can move on to the next step. From here, we increase the Lambda Meatgrinder function to have more than enough storage and memory to handle uploading the video to YouTube. I threw in a 60-second wait before increasing the Lambda function configuration in order to give the configuration change some time to complete. AWS moves so fast that the function will be invoked before the configuration change is done, which would then cause the upload to fail due to the size of the file. So after the upload is completed, we'll reduce the Lambda function configuration to the normal memory and storage configuration. Since we want an HD download later in the automation, we need to wait until it's most likely done. After 2 hours, we invoke the Lambda Meatgrinder function to check if the YouTube data API is saying the upload status is processed, and if so, a new Lambda function named Meatgrinder-ytdlp will be invoked. This is a Python function whose sole job it is to download our own YouTube video using our OAuth credentials. After this function downloads the video, it will copy the video to our S3 bucket and then respond with JSON on how things went. If everything went well, we invoke the original Lambda Meatgrinder function to create a new post on vBrownBag.com using the WordPress REST API and update the XML file we use for the RSS feed. Here's CloudWatch showing a successful completion of the Meatgrinder process. You can see where Meatgrinder reports the assets found in the S3 bucket, when it creates the post on vBrownBag.com, when it updates and uploads the RSS file, and then when it finally cleans up after itself. Thank you for joining me for this deep dive into the Meatgrinder process on AWS. See you next time.